The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. A lot of people know us from the 2018 eruption of Kilauea in the Lower East Rift Zone. Working under Hawaii Tracker on the Facebook group. Since then, we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption and try and prepare for the next major disaster that comes to our island.
Yeah, so we do that through two different programs. One is volcano education, and the other part is digital resilience, which we address through online groups on social media. So the way the two programs work together is that the social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well.
What we were working for really came about in the Mauna Loa eruption in 2022. Within hours of that eruption starting, we had the mayor, Mitch Roth, we had USGS HVO Ken Hahn on the stream trying to help flush out a little bit of the ongoing because it's so new. It's completely different from our previous major eruption, which was 2018.
One of the things that Talmadge and I were talking about was how do we deal with social media? And it was something we needed to figure out and get right. Our job is to get information to the public and make sure that the public get it as well as possible and as correctly as possible. When Philip and Dan started coming to you and live streaming the meetings, it was great because we were reaching more people than we normally would. So when the eruption actually happened, we had this relationship. The interviews we did during the eruption, the most fun ones were the ones with Philip and Dave because they were more relaxed, and we knew we were getting to the local community, and people were asking questions. So those were the best, I think. I just want to really give a shout out to those guys and how we worked as a team on this eruption. It really worked out well, and we got to a lot of people we wouldn't have normally got.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont from HVERI. We are the nonprofit Hawaiian Volcano Education and Resilience Institute. And this is our Hawaiian Volcano Tracker update for Thursday, August 1st, 2024. It's been a little less than a week since that intrusion on Kilauea's Upper East Rift was declared over. but there's been plenty of action on the ground to talk about over the past week, Dane. So we'll get into all that, the monitoring signals. We'll have a little bit of a data-heavy update today, but there's a lot of stuff happening underground for us to discuss. All that said, how are you today?
Oh, doing good. Yeah. Been a busy week, interesting week. I didn't know if we would be coming to you tonight or potentially a little bit sooner with how much motion in the ground we were seeing. So I'm sure Phil's going to go over all of those details. We also in the midst of our donation drive, and we're going to bring on Lou a little bit later to tell us a little bit more about that. So yeah, busy little program set up today.
Yeah, thanks, Dane. And as usual, Dane will be leading discussion on our chat and taking a collection of questions for us to discuss where it is appropriate along the way. So thanks for that, Dane. And I suppose without further ado, we'll get into our Hawaiian volcano summary.
Yeah, let's do it.
So let's shift our screen around here. And let's get into it here. Aloha, everyone. This is our Hawaiian volcano summary for August 1st, 2024. It's been about a week since the intrusion on Kilauea's Upper East Rift ended. However, earthquakes over the past week have continued at lower rates at the margins of that intrusion. So to remind you, this is a satellite image of where the intrusion occurred in the middle of last week, focused here in the area around Maunaulu crater, next to Pauahi crater as well, right along this turn in the rift zone right there. The earthquake rates since then have dropped off. So you see over the last week, earthquake rates have been fairly low, although they have been clustered in those areas that we just showed. The tilt meters that we see at the summit, this is a Sand Hill tilt meter. One of these lines points more towards the main caldera and one towards the south caldera, where we've seen recent magma movement to the southwest rift. Both of these signals began reinflating shortly after the earthquakes slowed down on the Upper East Rift. So that suggests that the pathway of magma from the summit to the Upper East Rift was disrupted at the end of that event there. However, as we've showed, there have been earthquakes still ongoing at the margins, and this is away from the center of intrusion right through here. So perhaps what's happening is we're seeing settling of this magma body, no longer being fed from the summit. That part ended at the end of last week, but the volume of magma that's still intruded in here could be redistributing itself just to spread out more along the opening that it's encountered. And that would be one possible explanation for seeing earthquakes at either end of that intrusion area. However, all the sites on the Middle East Rift and south of there are showing massive ground movements. I'll point out this is the Makai Makaupui station as one example. This is a 2-year plot with 3 components. This top one is east-west, north-south, and the bottom one is up and down. So in summary, what we're seeing over this 2-year plot, really that our data is within this very last sliver of the right side of the graph here. We're seeing the upwards component shooting up at a massive, massive rate. We're seeing the north-south component shooting to the south at a massive rate. Faster at first, slower, the points are closer together, but still ongoing as we speak today. And also moving, in this case, to the east as well. At east and maybe wiggling back a little bit there. That's just one representative station. But if we were to bring up the USGS map, where these blue stars indicate these GPS stations, this is the one we just showed you at Makai Makapuhi. But if you see the one just north of there at MMAU is also showing signals, as is the one north of that. All these in this area right around Makapui crater. And here's the NUPM station, also showing significant movement. The signals aren't quite as large, but if you go further to the east, to near Napau crater, right through here, you also can see signals on those stations as well, including perhaps a little bit of upward signal here. So when we start seeing upward signals on these on-rift GPS stations, that raises a possibility that magma is actually moving into these areas of the rift. It's doing so with less earthquakes because it's being fed not by the pressure from the magma chamber flushing everything through, but rather by, think of it as gravity redistributing the magma within this blade in here to spread out, right? Gravity and the pressure of the area, and pressure wanting to migrate to where there's less pressure laterally. So that is as far as we're seeing this effect of ground motion, but this is true all the way down to the coastline as well. You can see the station all the way by Ho'oleipali by the coast, also moving very fast within the last week or so. So this effect is all happening uprift of Pu'o'o. Pu'o'o crater is here. And if we look at Pu'o'o itself, we do not see those signals. Maybe a little bit of adjustments, but Pu'o'o is still moving downwards at its regular pace. It has not changed in nearly 2 years, as has its southward pace and its eastward pace, maybe slightly more so. So everything is contained within this Middle East rift zone, uprift of Pu'o'o, meaning that there is no threat to people from this activity. This is all within Hawaii Volcanoes National Park, and any activity through here, an area the volcano prefers to erupt from, as you can see, the big scar of the Maunaulu eruption and a big scar of the Pu'o'o eruption. This is normal for Kilauea, and this is not anything to be overly alarmed about, apart from the fact that we're now seeing the reactivation of the East Rift 6 years after the 2018 eruption. So that is Kilauea, and the USGS at present in their update are stating that continuing earthquakes and ground deformation in the area between Maunaulu and Makauapui crater, slightly downrift in the Middle East rift zone, likely reflect local adjustments due to changes in pressurization from the intrusion. This activity does not currently indicate intrusion growth via new magma being supplied from the summit. And in conclusion, additional swarms may occur with little or no warning and result in either intrusion of additional magma or eruption of lava. That last statement is fairly similar to what we've been living with for many months now, but this is the explanation from the USGS here of how these local adjustments are not from new magma coming from the summit. So that is Kilauea. Very quickly on Mauna Loa, earthquakes have been at background levels there across Mauna Loa summit. Deformation cross caldera has continued extending as magma fills Mauna Loa below ground, with maybe a little bit of extra scatter in the data, perhaps suggesting some lateral adjustment in response to Kilauea over this past week. We'll have to wait to see if this data cleans up by the next week to draw further conclusions. On a short term, looking at Mauna Loa tilt, there is no obvious effect here, and so Mauna Loa continues filling, recovering from its 2022 eruption undisturbed. And that's our Hawaiian volcano summary for this week. Okay, so with that Cliff's Notes version out of the way, we'll turn to our observations here on Kilauea. And I thought we'd start with just our views. So here's the Maunaulu camera looking down rift. This is Makauapui crater right through here. Kananui Ohamo is this lava shield right here in the foreground. Just behind there is where Napau crater is. So we're actually looking down a rift here at this area where the magma is possibly moving through, and certainly the ground is adjusting quite a lot. Right, there's 3 stations I showed you showing the most movement are more or less in there. Let's wait for this to come through dawn again. So we're more or less in there, more or less in here, and more or less in here, something like that. So this is the area showing the most movement right now. Looking at the other direction from Maunaulu, looking up the upper east rift towards the summit. I can put that on the animated view as well. But there's not a lot of action there. You see the shadows coming through, the forest is there. There's really not a lot to see. Mauna Loa in the background, still nice views of this upper east rift area. And finally, from Kaluapele, from up at Wakahuna area, the pan and zoom camera has been repositioned to look down towards Maunaulu. Here's Maunaulu lava shield on the horizon of this camera. This is K2 camera, and showing the calmness and lots of interesting colors with the light here within the main caldera. So those are our live views, the near live views. But there are additional views that came out as well. We have a report from the USGS of the minor cracking on the chain of craters road from their intrusion. So here you can see that they've drove down the road on the 23rd. You can see these series of cracks. I can try to highlight them for you guys. It kind of go like this. There's some more right in here. These are fairly small on that one. Maybe I can try to click through here and see if this will load. Yeah, there we go. Do the original. And let's blow it up there so you can see it perhaps a little better. There, those little cracks. Those ones fairly minor. But let me go back here. Go back and back. And there's another one with a little bit more buckling. You can see the buckling of the asphalt here in the background, there and there. Has all these different slivers of rock, blocks of rock that are underground, adjusting from this magma moving underground. They're all moving like a stack of books or magazines. They're kind of sliding past each other. Some of them might come up towards the surface and cause bulging. Others might slide past each other. And if these things aren't perfectly the same width, you could cause openings of cracks that could then have material fall into it. Those are the kinds of things that you could expect. So those are the USGS surveys there. But we also have some other views. This from the national park on Facebook, posting when they had actually reopened the road to bicycles and pedestrians as they were still assessing the road, and deemed it safe for pedestrians and bicyclists who are not very heavy, but not so for the larger, heavier vehicles at that point in time. So there's another one of these views of this crack, bulging, crack coming across the center line here. A little bit of offset possibly viewed right there. Here's another one, closer up with a cone nearby there. See if that gets any bigger, yeah. Another view, similar kind of cracking, left stepping, steps to the left, steps to the left. It's typical of fault rupture at the surface. Basically any gap between two moving blocks of rock is a little fault. So these are technically expressions of fault movement at the surface here. So let's see, did I get through more? I don't know if I did. There's some more. This is looking across off the side of the road where you see perhaps pre-existing cracks widening, or perhaps these are some of these. This one might be a new crack. This one over here, we can see vegetation in it. So it likely was a pre-existing one that perhaps widened. Other views here, a series of cracks coming across. These are so far not huge like we saw at the eruption site on the Southwest Rift last month, but still significant of concern to motorists and other vehicles here. Yeah, there we can see a little bit of offset in that center line, a little bit bigger crack right in there. So that is when a park reopened the road. And then we have here a post by one of our dedicated viewers, Yvonne Bauer, who put out this post, who the park leader then uses as well, to take us on a little journey as she walked down a chain of craters road to examine these cracks. So I'll go kind of quickly through the non-crack ones. Here's Luamanu crater, walking through the rainforest. Luamanu crater, close to the 74 of July fissure. Puhimau thermal area, right through here, coming near that South Caldera wall. Here the road crosses a fault line near Hilanapali turnoff. See that sway in the road there and a bulging happening there. Pretty fantastic. And there's that turnoff to Hilanapali Road right there. And Devil's Throat, which has been a crater that has been enlarging over the decades already and has visible cracks around the outside now. So I have not been there in many years to know whether the cracks that were previously there collapse in or not. but certainly there are cracks and there's ground collapse around Devil's Throat as well here. This is the May 73 by Hi'iaka crater pullout that flowed into the crater across the road there. And there is Yvonne checking out these cracks on the road here. Nice to have some scale, human scale there. More buckling, close-ups of those cracks. This is a 79 lava flow of November near Luamanu crater. Pawahi crater, Maunaulu here in the background. This was a couple of eruption sites right through here, 73 and 79. Maunaulu parking area. So this is where I'm trying to get to, really. This is how we'll wrap up this part of our segment here. But right there in that middle divided area, big cracks and lots of buckling. Also here on that return route. Looking at that. All Maunaulu parking lot angles, as well as the access road from Maunaulu parking lot towards the trailheads over here. You can see that big flow there in the background and lots of new cracking across that road right there. And the escape road that leads up by the east side of Pawahi craters and all the way up to Nahuku lava tube, also showing some cracks in this area. And this is near where that escape road tilt meter station is more or less through here. So pretty cool. And mahalo, Yvonne, for sharing those and allowing us to share them here as well. So that is first-person experience of that. Then a national park comes out on the 29th. They have reopened the road to vehicles, except for the Maunaulu parking lot and access road, which they at that point in time had still extra work to do. So they repost some of Yvonne's pictures right through here. So this is fantastic. I just thought I'd show you the originals. And then finally, on the 30th, they reopened Maunaulu parking lot as well, rerouting traffic around the cracks caused by that recent intrusion. They include this photograph, which is on the east side of Maunaulu. Here's Maunaulu. Here's that cinder cone next to it, which is called Pu'u Hulu Hulu, like the streaming service. All through there. So, and here's some big cracks on that west flank of Maunaulu, near where that intrusion was centered, right through there. Once again, we can see there's vegetation in the cracks. So these are not new cracks in this case, but perhaps pre-existing that have been significantly widened by this intrusion. And that makes sense, right? If you have a crack already there that you can use to spread your ground, why would you make a new one? You just use the one that's already there. So that is the visual part of our update here, showing the physical changes on the ground as a result of the recent activity there. So with that, we can now move to our earthquakes. So let's put those on screen here. And I think this is a little small. Let's get this to the right size and get it centered and pull up what we like to see. So here's just the last 2 days of earthquakes, showing you the most recent activity. And I'll zoom in on Kilauea to start. Not a whole lot under the caldera, a couple. These are colored by depth, not by time. So you can ignore these colors right through here. But the depth, the reds are shallow. Let's put the key up so you guys can see. Reds are shallow and the blues and greens are deep. So all shallow earthquakes apart from one deep one right through here, near the magma sources. It doesn't have, the purple one has got nothing to do with the red ones. It just happens to be in that same column of land, but probably 20 miles away vertically. So we have activity still at this uprift end of Puhimau crater. There's a little bit of cluster by Maunaulu, and there's a little cluster over here by Makapuhi, with one straggler over by Nepal and Mar stations that we mentioned are also showing signals all through there. So those are the earthquakes for the last 2 days. Zoom it out here just to show you the full pattern, which is that of earthquakes deeper under Pahala. There are a couple shallower flank earthquakes offshore here, and otherwise background earthquake under Mauna Kea here. If we pull up the last 2 weeks, that'll include the intrusion, and you can see a lot more of this pattern in the Middle East rift here, that whole sequence. So if I flip it from 2 weeks to 2 days, you can see what I mean about the intrusion affecting the margins rather than the center here, right? The middle part any edges there. So viewing by colored by depth is just one perspective. We'll also look at these viewed by time. So now the red ones are the most recent ones. The most recent event currently is down under Pahala, 20 miles, 19 miles deep, unrelated to what we're seeing here at Kilauea. But Kilauea ones, you can see the oranges have been still occurring as well, all through here. This is the last 7 days, once again. The last 1 day, a little reduced from what we saw over the last 7 days. But compared to the last 30 days, you can see it's actually fairly localized on either end here. Continuing on our 7-day window here, our most recent event is happening right now. Let's see, it's 5:27 p.m. So we had one at just before 3 p.m. right in here. There was one at 2:20 p.m. and before that it was 7:20 a.m. So really much slower. Whereas last week when I was reading you these, I had to go through a whole bunch more before I even got through a single hour. So the most recent large one, about a 2.4, that's still a decent size, but not nearly as big as the ones we saw earlier in the week. So let's come and rearrange our graph by largest magnitude. And this will bring us to what happened on Monday, because we have here 3 earthquakes at the top of the list. A 3.7 at 9:40 a.m. on the 29th on Monday, a 3.4 at 9:43, and a 3.5 at 9:44. Those, all 3 of them in close proximity. Maybe you've seen, here's the blue dot right there for that 3.7, and 3.5 is just about on top of it, and 3.4 is just about on top of that as well. And so there they are, all right through here. This is clearly the south flank. And so the magma is up through here. It's piled up more or less in here. It's maybe trying to spread out that way and that way. But it's also pushing the land in this direction too, all the magma wedging in here, right? It's not unlike trying to cut a big tree and you start hammering wedges into the side of it because that's the way you want it to move, right? So we have a magma wedging itself in right through here, and that's driving the south flank to the south here. So 3 moderate earthquakes right through here, showing that movement of land and the opening of the rift zone through here. If we hadn't had GPS signals, that would have been a big clue that there was more to the story to come still than we saw last week. But to really get to all that, we need to get to the GPS. So we'll turn to monitoring beyond earthquakes next here. Let me get that on the screen for you guys. So to set the scene here, once again, we'll just remind you of the inflation area right through here. Right, Pauahi crater, Maunaulu summit is this crater right through here. Pu'uhuluhulu streaming service cone is over here. Right, that's not actually what it means. Hulu means hair. So Pu'uhuluhulu is the shaggy hill. It's covered in forest and vegetation with lava flows all around it. Nice example of a piece of older land surrounded by younger land here on Kilauea. So that's where the center of activity was, right through here, not that far from the end of Maunaulu turnaround, right through here. It's not surprising that this area has so many cracks. Right, the west flank of Maunaulu we saw had cracks as well, right through here somewhere. But right now we're seeing deformation all the way past here. And this is Makapui and even to Nepal all the way over here. You don't see as much because of the forest. Right through here is a gray area. You don't pick up the signal as well or at all. But clearly the center through the first 3 pulses was here before we saw that 4th pulse seem to migrate further to the east. So this is where we were at the end of last week. Last week, Friday, the USGS's update stated that the unrest, which began on July 22nd, had ended. They note that the 4th pulse ended by midday on Thursday, just before our last week's update. It was kind of winding down as we presented our update to you guys. And everything is back to normal at that point in time. I won't read anything else of this update. I'll just move on to the next one of relevance, which I'll pull up from Tuesday, where they are noting that there was no reactivation. However, at that point in time, they came out to say, let's see, where's the sentence I like right here. Analysis of recent data suggests the intrusion as far as Makalapui crater in the Middle East Rift Zone, right there. That's the key thing. So by Tuesday, they're noting the effects as far as Makalapui crater. Right, so just to refresh on this graph, that's over here. Right, so perhaps that fourth pulse might have moved the center over in this direction. But that was as far as they said on Tuesday. And today's update is the one that adds this extra line that I highlighted in our summary, that local adjustments due to changes in pressurization are likely the cause of earthquakes and continuing deformation in the area all the way to Makakui crater, and I would add today, potentially beyond. So that is the USGS catching us up from last week to now. And as of today, no significant changes and minor activity and deformation continuing is the official headline. So we'll look at the data in a little more detail. So let's come up here to the top of this page and look at the tilt for the last week. So here we are. Our scale is 6 microradians top to bottom. That's decent. That's about normal. Not too zoomed in, not too zoomed out. You can see that immediately following that intrusion, we're still fluctuating deflation inflation events, but more or less flat here. And it was really on the 27th following that intrusion that we start seeing a more consistent increase in tilt at the summit. And further, we see that yesterday it seems to have accelerated a little bit more as well. And so we'll see what comes of that. Right, the bottom line is the summit is inflating again. Magma is coming into the volcano. And right now it seems to be backfilling in the summit area. Over the last week, earthquake counts look pretty flat because the intrusion was largely over 1 week ago. So not a whole lot of distinction in this view right through here. We look at depth over time, we can see that in the shallow zone, there is the end of that intrusionary pulse. You can see the couple of little adjustment pulses that followed there and there. And it seemed like it might have been picking up a little bit more intensely in this latter part of the week, but seems to be slowing once again right now. The Deep Pahala zone is just showing its regular random background pattern here in the blues with nothing really distinctive to point out. So there is the 1 week earthquakes. In this plot, we can also see these blues showing those deep earthquakes under the magma source, the near vertical source of Kilauea. Kilauea is thought to have various sources, one from the side of Pahala, but also vertical sources beneath the summit right through here. So interesting that we're seeing activation of these areas all through here, even some of the greens and greens further afield here, all surrounding this area of adjustment. In cross-section, there is that deep feeder source from Pahala that might come over. And here are the deep ones now that might be coming from our deep source up. And so this is just showing the possible multi-stranded pathways of magma, right? Like roots of a tree that can feed into this volcano. Certain ones are preferred, but there are times that other ones can activate as well. Looking at the last month time frame, I preferred a slightly zoomed out view to give us more context. We can see that building up to that intrusion, we were at negative 10 microradians. We ended at almost positive 10, 20 microradians of inflation over about 3 weeks to lead up to that intrusion. And that doesn't even count all the previous inflation we had in the months before that. As that intrusion occurred, we see deflation occurring at the summit and a period of stability with neither inflation or deflation, and then picking back up again and accelerating here in more recent days. And that's just a summit signal only. Uekahuna at the summit is this blue signal right here, which is also the same signal as the blue line on a sandhill tilt meter right through here. So both of our summit signals are showing inflation as well as the south caldera. Well, I'll just move past the last month. We can't really pick out any detail from this overplotted graph. And here's a context of earthquake counts over the last month. And here we are at fairly steady, but well below that peak that we saw a week and a half ago. These are earthquakes per day. So we're currently in the range of between 100 and 200 across all of Kilauea. If we look at earthquakes per week, this week is down. This week we're down in a range between, call it 600-ish earthquakes, 700 earthquakes or so. Whereas last week we were closer to 2,500. So this is also following that pattern. But if we zoom it out all the way to earthquakes per month, then we're still barely now into August, but all of July adds up. And so July is officially over 5,000 earthquakes that month on Kilauea, the most earthquake-prone month of the last 5 years here. A lot of dynamic action on Kilauea. Looking at the GPS now, this is our north to south across the main caldera measurement here. And this is a whole year of time. So we really have to zoom into the right end of the graph to look at what's happening now. Most recently, we see this line moving upwards. So the sides are spreading apart. Magma is filling the summit and pressurizing there. During the intrusion, you see that contraction. And prior to that, you see the buildup of magma that at the time was filling all the summit and the south caldera and the southwest rift following its intrusion and eruption on June 3rd. And it was also intruding the Kauai and Upper East Rift Zone. So a lot of magma was trying to fill in every single area it could. It popped open a little pathway, and that was able to relieve the pressure temporarily. But as we zoom back out again, these little drops are all intrusions or eruptions all through here, and the overall pattern is that of magma coming into the volcano, possibly even at faster and faster rates over the last year. So that does not appear changed. And so the volcano has to keep spreading and adjusting, stretching, cracking to accommodate all this magma that's coming in. And it's all going to go somewhere, whether it's underground or out of the ground in eruption. So that's the summit line. We come down to the Pu'o'o line. And once again, compared to last week, we have fewer data points actually showing up as erratic. Our most recent points here are showing erratic, like they're further down, like there's more contraction in the rift zone. But we've been seeing this kind of pattern for a while here, and all this other data for the rest of the month seems to have been cleaned up now. So I suspect there is some kind of noise in this station, but in a possibility that it is not noise, the rift zone is actually getting closer together, contracting, which is the opposite signal from magma coming into it at Pu'o'o itself. And as we've described, the signal is different now at Pu'o'o than slightly at rift. So we'll see if this changes in months to come here. That's the big picture of the GPS. And we'll go into more GPS detail, but I thought we could also examine our tilt today. So 2-day tilt showing a more recent increase at the summit. We've looked at these ones already. I'll kind of scroll down here to Kīlauea, a station on the east side of the summit, also showing that same pattern for the summit line in the blue, and a green line pointing more towards that connection to the Upper East Rift Zone, showing the deflation as a result of intrusion, but continuing deflation there too, which was also the pattern beforehand. So there may still be some little movement between those two areas there, but not enough to cause any earthquakes or to prevent the inflation of the summit. So Kīlauea, Sand Hill is that similar pattern. Escape Road is not really showing a whole lot of inflation or deflation all through there, but does catch the 4 pulses, 1, 2, 3, 4 right there, or 1, 2, 3, 4 right there. That came through, but right now it's settling, nothing exciting happening tilt-wise. And Pu'o'o really didn't even show the pulses, honestly. It's just still deflating at the cone. Further down the rift zone at Jonica, all we pick up are the extra noise of the ground shaking with earthquakes, with the tilt signal flat to decreasing here as well. That's the tilt. Looking at GPS now, let me just come up to the top here. And I have just rearranged these a little bit to help us examine these in a little bit better pattern here. So the summit stations at the north edge of Wikahuna, what we can say is The stations at the summit are all dropping down, at the northwest, at the east, and they're all kind of sagging in response as well. But more importantly, this is a 2-year plot, I should mention, right? So everything's compressed. So it was dropping down, but still spreading apart. Right? So that's interesting to note there. Some complex adjustments at the summit, but down, down, crater rim, down, and outlet down. That might have been more so during the intrusion, whereas the time since then, maybe it's stabilized or maybe slightly coming up. And it's really hard to tell on these 2-year plots because the data is really so squished into this right-hand part of it. But you can see the big picture here. So to the southwest, 1.5 miles southwest, down a southwest rift at Cone Peak. This is a station that, following the eruption last month at the beginning of June right here, was still going upwards, 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 until this recent intrusion. And now it has stopped going upwards again. And the same is true to the south at Ahua, which was going upwards, upwards, came down. It's closer to the summit, so it may actually be starting to wiggle back upwards as well. And so all the summit stations are kind of showing that sagging with some little complications there. The upper east rift, as we come closer, it gets a little bit more complicated. We get to Puhimau area. Puhimau had a big jump to the north during that intrusion, but has since stopped moving and has kind of resumed its previous trend. Puhimau was moving up fairly fast and seems to have stabilized as well. Right, so this is the area at the north end of that earthquake swarm, and that might be why you can see it with such a big movement to the north as well. We, to recap, talked last week about how the intrusion began under Maunaulu, and then it seemed like as those dikes propagated upwards, they then spread laterally, both up rift to Puhimau and down rift towards Maunaulu and Makapui both. So it may well be that this is what pushed Puhimau to the north, with other station at Puhimau showing that same pattern, but this station was only installed in 2023. So you're getting a different scale on the left and maybe a little bit more detail in the data here. So that's Puhimau. If we go a little bit further south, Devil's Throat. Devil's Throat had some little wiggles east, west, and north, south also. But what's interesting is that it actually has been dropping. Right? It's actually been dropping down. So that area seems to be losing magma to the south and north as well. Maunaulu Station, just to the east, has so much scatter, it's hard to really say anything definitive here. It does appear that, to me, that this scatter is in a downward direction, and downward direction. So I would, in this case, just really guess that if this is not the same kind of scatter noise as we see elsewhere in the plot, that Maunaulu may also be dropping. And that would make sense. If that's where the magma intruded the most and it's moving away from there to the sides, then that area should settle down. Same with Devil's Throat, here and here. Then we get to the Middle East Rift. Now we get to the Middle East Rift at Kananuyohamo. It's got a couple of stations, NUPM and MMAU. And these, you can see, are moving rapidly to the west, and a little bit to the north. And NUPM is not really convincingly going upwards. There's a lot of scatter through the back part of this graph here, so I wouldn't really say I'm convinced here. But you get to some of the other stations, MMAU here, also showing massive westward movement, showed a jump to the south, but maybe more stability since then. But here is starting to hint at some upward movement. And as I mentioned, when these stations on the rift start moving upwards, that is one of the likeliest signs of magma coming into that area to push things upwards. You can also have, let's say, the magma pushing the flank, and the flank happens to be moving over this sliding zone, this fault line, and its fault line is not always perfectly flat. It might have bumps, and so it could be that magma pushing the south flank could cause a flank to move over a bump, and that could cause a land to rise as well. So there is that caveat there. But as we start looking, we'll see that other stations are also moving upwards, and so it may be actually potentially a magma signal, and this may become clearer over the following week. We'll see what the USGS has to say about that as well. So that's about 7 miles east at Kananuyohamo. The Kane station itself is actually on the east side of Kananuyohamo, closer to Nepal crater. So that station, and the KERZ station, which is a newer one, also installed in 2023. Similarly, zoomed in scale, are showing that same pattern as well, right? Where we see big drop to the west, movement to the north. So it's a northwest and up, right? This one was a little more convincing. There is scatter through the last 2 years through here, but this looks like it's moving up. We'll have to wait and see. And the same caveats for the data being clean at the right end of the graph still apply. So sometimes this is a little tricky to really interpret. Looking at the KERZ station with less data points, now this looks like it's within a scatter. I'm less likely to say that this is a clear signal right than over here. But when you combine it with this, and the fact that these are really side by side, then it makes sense that could really be a real upward signal as well. Kīlauea is further to the east, showing some funny little wiggles through here. That one might be noise. Little wiggle here, not quite so convincing over there, right? You don't really see an upward, maybe a little bit of a wiggle, but still some scatter and some noise there, not convincing. The Okita station is south of Pu'u'u, south and west. This thing is the noisiest one we have, and it looks like it's going to the west, and then to the east, and then to the west, and to the east. It looks like it's going to the north, and to the south, and to the north, and to the south. It's like really ping-ponging around. It's going up and down, and more down. So it's hard to tell if this data is actually real, but if it is, this station is a piece of rock that's loose in there, and it's getting pushed in every direction every single day by what's happening all around it. And that could be the loose tooth in the mouth there, Middle East rift. So I'm curious about that. We'll see if this data gets cleaned up as well. The station that's the next two are Pu'u'u and Jacuzzi. Our line signal that goes from north-south across the rift zone is measuring the distance between these two. And this station at Jacuzzi was the one that was showing more of this movement to the west over here. And this is what we're seeing corrected as well by the recent GPS data. So really curious to see how much, if their corrections affect all the stations potentially, or if it really, it really seems like it's too widespread for it to be all noise in the data. And perhaps the magnitude is a little off, but we're seeing the pattern all across there. And if we go further to the east, right, at Pu'u'u, we don't see those big signals. We go east of Pu'u'u and Jacuzzi. There's a station also installed in 2023 called RKAR. It's not showing any upward movement or any northward movement or any westward movement. R931 further over similarly. So further down the rift zone, all looks good. You get to the flank just south of that Upper East Rift and Middle East Rift, and it's moving as well. Idaho, massively to the south. We don't see so much of the upward movement because now we're really pushing a flank. We're on a flank. So there it goes to the south at Idaho. Mulivaio Pele, there it goes to the south. Really fast too. What's next? Hulepali, we pointed out on a map, going fast to the south. MP3R from 2023, not showing this pattern. And this is the one that's further over to the east, south of Pu'u'u, not showing that pattern anymore. At Pool Point, no live data. Kaina Point, all the way at the coast. This seems to appear to be showing some southern movement as well. And if so, this is the furthest station in the field showing effect of the flank moving. We'll come to the map here in a minute so you guys can see where all of this actually is. But to be complete here, we'll go through the southwest rift, 4 miles down and near the eruption site. That was rising until recently. There it is actually dropping now. So it's now finally cut off at the eruption site and further down rift. Here it is further down rift, 8 miles down the southwest rift. Installed in 2024, but showing nothing unusual happening. The south flank down in that area of the southwest rift is not showing anything unusual. No acceleration of southern movement anywhere. No big movement upwards. So really what you're seeing is how this is affecting largely the east rift zone and south of the east rift zone. And that's the segment that's adjusting on Kilauea right now. Now to round it off, down in the lower east rift at Jonica, no change for 2 years. And this station, I don't have an exact mileage there, but I'm going to guess it's like maybe 25 miles or so. No unusual signals recently there either. So that's the GPS as complete as we can make it. I want to pull back up to the south flank station here, this one. So we have a station at Makai Makapui, which is actually quite close to the rift zone. It does show upward movement a little bit, and that big flank movement there and there as well. And Kīlauea Trail, I wanted to end with here. Kīlauea Trail is a station that I, for a long time, have been saying is a canary in a coal mine, the bellwether station for the Middle East Rift, the one that is the gatekeeper that can actually open or close that pathway to the East Rift. And you guys who've been following for a while, maybe remember how excited I got in the middle of 2023, end of 2023, when I said, look, it's starting to go south finally. It's been years since this has actually changed. Finally, now maybe the rift zone will open up over the next year. And so it's been moving south. It's been moving south a little bit. And here is the last week. It's just crashed to the south in a ridiculous fashion here. Just really booking it and still moving. The data points are not piling on each other. They're still spreading out here, showing this movement is ongoing here at Kīlauea Trail. Yeah, and so for some context, I'm going to pull us back to our 10-year plot. These are the last 10 years. This is Kīlauea Trail. Kīlauea Trail normally moves to the south with occasional little adjustments from earthquakes. Here was the intrusion, 2018, 6.9 earthquake, recovery, southern movement, all the way into 2021, right here. And then mid-2021 is when it starts moving back to the north. That's when our rift zone closes off officially. It's been going north. And then here we are at the very right end. Suddenly, we're zooming back to the south, almost vertically on this scale. So that's really fascinating there. That's the pieces of land, the blocks of motion on Kilauea. So to show you where that all is on a map, there's all the summit stations. So the summit stations that are dropping are these ones all through here. Those are the 6 ones dropping. The Southwest Rift is dropping. We talked about how Puhimau was the one that got shifted to the north. This is the one that moved north, but was still not really dropping too much. The drops are happening at Maunaulu and Puhimau right through here. And yeah, right through here is where those drops are occurring. And further east, let me zoom it in further now. Right, these are the 3 stations showing that most movement. Right, and when I mentioned Makai Makapui being south flank right on a rift zone, that's this one right here. So it's really picking up both the flank and this potentially upwards rift zone signal. Here at the Makai station, which maybe has a combination of the south flank moving over a bump effect and the magma pushing it up effect, maybe you get both there. We can estimate, it looks like this data point right here is somewhere near just below 2 centimeters, we'll call it. And we'll come to maybe this line as a generous baseline. That's at -4. So you're looking at about 6 centimeters of uplift in the last week in this area. Right? You're looking at, what is that? 2 inches of uplift in a week in an area where magma is no longer intruding. And so that's really what's changing the fastest and what's the least stable. And so if the situation is not stable, something else will continue to happen until it stabilizes, whether it is magma continuing to move as far as it can, pressurizing, working its way towards the surface, being repressurized by the summit as it reconnects. We'll have to wait and see, but clearly we can see the data is still moving fast and the story is not over here. So that's the Makai station, and further over, there are our Kananoyohamo and KERZ stations right there. Let's see if we can get the Kamo one up here. The Kane one up, I should say. There's the Kane one. And yeah, there is maybe, in the context of 2 years, what appears to be some upwards movement, and certainly northward and westward movement. And coming back over, this is Kamoamoa right through here. Kamoamoa is not showing those signals. Slightly, but nothing upwards for sure. Pu'o'o is not showing that either. Ukita, the one that's the wiggly tooth, that one's right here. Right, so that's south of the rift zone. And if anything is wiggling weird, it's right in here. Right? Jacuzzi showing some noise and some wiggle also. And that is as far as the magma may have gotten. This is Pu'o'o right here. Right? So for anyone who is concerned, the lower East Rift is way, way over here. There's no connection right now from what's happening now to any threat on the lower East Rift. All right, so that is a lot of monitoring. I'm going to end it with our satellite and just one last historical point here, but we'll come back to our INSAR images on the MOUNT platform. These are automatic satellite-derived images showing ground motion every 12 days. Our most recent pass that came through ending on a 26th from this system is showing, it's hard to tell really, right, an inflation center further to the south by the Kauai. Maybe if you look very closely, you can see some of these little fringe lines right in here, but they're not really picking up too clear. Right? But that's what we know from the USGS data set. Intrusion was centered down here. And otherwise, what you might pick up is there appears to be some deformation right in the main crater as well. So perhaps as the magma drained out from underneath the summit, you had a little bit of settling here as well. So we'll look into that in the future too. But this is this past 12 days, the prior period to that. The magma was really in that South Caldera. The 12 days prior to that, it was further in the Kauai. The 12 days prior to that, it was closer to the South Caldera. And prior to that was our eruption into the Southwest Rift on June 3rd. So that's the recent history since the last eruption. The magma that flushed out to that area was still feeding down into there, but coming into the volcano fast enough that we're going to move forward in time now. It was backfilling, pressurizing in the South Caldera, pressurizing in the Kauai, starting to pulse its way down to the Upper East Rift as we have seen previously. Still building at pressure. And then finally, relieving that by an outflow over here, right? And if anything, you're maybe seeing some extra deformation in the Kauai zone that is off the edge of the map here. So that's the satellite, just to kind of bring us up to current. And I thought I would end historically before our break here, just talking about the history of magma supply here. And so the USGS has a professional paper, 1806, that's called 200 Years of Magma Transport and Storage at Kilauea. And we've referred to this paper before many times. And they have these series of panels of where magma came into Kilauea from 1950 through the end of the 60s or so. And the actual pattern isn't, the details of like what happened and what order is not what I'm trying to get at here. My point in showing you this is to show different pathways of magma from the source into different parts of the volcano, right? So that's what we're really getting at. Because there can be times that the magma can actually be feeding into the summit and in parallel also feeding into the rift zone, right? Not going to the summit and zagging over from the top, but actually migrating over at a greater depth, 4 or 5 kilometers down, 2-3 miles down, and moving to the rift zone that way. So this is 1950. Magma was coming up into the main summit, also filling the rift zone. So it's such that by 1952, the summit magma had already come up to erupt. The next batch of magma into the volcano seemed to divert into the rift zone. And this is all from after the fact, from trying to unmix the magmas, figure out what had to be there to mix to flush it out through. So that's how you can see that some of that blue 52 magma was in the rift zone already. And it got mixed with what was going to erupt in 61 out of Halemau to the top here. So once again, path of magma bypassing the summit shallow zone to feed the East Rift right through there. I'm going to advance it one more time here, 52 to 54. During this time, there is no connection to the rift zone right through there. Magma is coming up into the caldera, filling the caldera, and you have an extra special, very extra weird eruption, 54, that comes up from deep, deep down, does not mix with any other magma anywhere in this pipeline, anywhere in the volcano. So it bypasses everything, comes up to the surface, and erupts at Kilauea. Totally independent pathway or strand to come up there. Right, so that just shows some of the weirder stuff that can happen there. So in 54, following that eruption, there's a little separate bucket of that magma left, a little red spot right through there, in the 54 eruption. You still have some magma that's going to eventually erupt in 61, sitting in the magma chamber here in green. Some of that had already moved into the rift zone in green here and actually intruded Kīlauea crater in 54 to 55, ahead of a 55 eruption down in the Lower East Rift, right through here. So once again, magma coming up. This pink stuff didn't actually get to the summit yet. It goes in the rift zone first, and then later comes up into the summit to erupt. So let's advance. What's my next? So here we go, 55 is during 55 eruption. Summit area is still the same, but now we have at Kapoho magma coming out of the ground, and it's mixing the green stuff and the blue stuff all through there. Advancing to between 55 and 60, you're now feeding more stuff into the rift zone right through here. You have an extra weird straight from depth patch to Kilauea Iki in 59 that actually mixes with the 54 stuff a little bit. So those two separate pathways that don't mix with anything else mix with each other several years apart, right through there. So once again, you see this pathway bypassing the rift zone, or the summit to the rift zone. 6061, we saw the magma that was hybrid and Kapoho flushed out. It was that leftover from 55. Then you got the 52. Then you got the 61. Then you got the 67 and 68. All come out in that 1960 eruption in Kapoho. And that's how you can tell that the magma had to have actually split paths to go in a rift zone well ahead of time to cause this mixing for an eruption to occur years later. And that's how they're tracking this back in time. I'll advance again to the final slide here, 61 to 68. This is the period of right before Maunaulu, and then you have that eruption of magma to the summit. The pink stuff here sits in the rift as well. And here's where you really have many magma batches coming from the mantle from Maunaulu that come up. And not only do they come and feed the summit area, they are largely coming over to feed the rift eruption as well. And so it's thought that there are actually multiple paths into the East Rift Zone from the summit area. The one at depth it seems to be the most well-established, longest lasting one. At various points in time in the volcano's history, there have been proposals of a shallow pathway from the shallow summit pathway storage chamber to the rift zone as well. That may have been there, and maybe that since that upper chamber is temporary, it changes shape and character through the life of the volcano, that maybe that pathway exists sometimes and sometimes it doesn't, right through there. So all this to say, and I'll just let this play through now, and maybe let's make it actually play through at normal speed, and you guys can see here. I mean, one last pause here. From the deep zone of magma coming up the volcano, they identify 3 reservoirs, a shallow one, and there's right there. The deep one, most of it coming through here that connects to the rift zone right through there. But they're also noting the 3rd reservoir, the deep magma system off to the sides there. So this is magma that rarely ever comes up to erupt, but it can actually move up into the rift zone to fill and repair after big earthquakes and collapses. Right? So that's what we think happened in a rift zone following 2018 to 2021. That signal of magma in the rift zone was probably coming from below, and now we're looking for a signal coming from above, coming off in that direction. So now I'll play it, right? So all this is just to point out 2 things about this current pattern that we have going on. One is that the pathway of magma from the summit to the rift can change. And it's not always true that if you see a signal at the summit, well, I'm not saying this quite right. It's possible that the magma can be diverted to be feeding both the summit and that east rift at the same time, right? And so if something like that were to occur, then you might still get inflation at the summit. That might suggest that you're not feeding magma to the rift zone, but you might have an extra path of the rift zone from that source below, and you might have a trip coming in. And I don't know what's happening now, right, at all. I'm relying on USGS like everyone else. But knowing that this has happened in a past does bring up this possibility and this consideration now. If activity continues in this Middle East rift zone, continue to see propagation, maybe there's another path of magma into there that's not directly through that summit, right? That's just one caveat number 1. And the second one is that to see this migration of deformation, here, let me pause this. Let me pull back together earthquake map on the screen just so you guys can see. Nope, that's not it. Let's make it this one. Yeah. Okay, so the last 30 days, all the earthquakes in the last 7 days here on the edges, right? So the second point, the second caveat is that if the magma is not getting pressurized and fed by more magma, then it doesn't have to move with earthquakes, right? It can actually be moving through pathways that exist. They can pressurize to fill them, but maybe it doesn't have the pressure to actually crack new rock and propagate a fissure, for example. But that it might mean that it actually could fill areas without a whole bunch of earthquakes, and that seems to be what's happening. No earthquakes, maybe in the middle where the magma is the most mobile. You're seeing them at the edges where the magma is trying to push still, perhaps, right? So that's the other caveat. So depending on the state of the rift zone and of the flank there, if there are open pathways that exist, there can be times that magma can move without causing earthquakes as well. So those are the two caveats to keep in mind, the nuances that we can layer upon the interpretations here as we try to watch what's happening in the next weeks ahead. All right, that was a lot of monitoring. That was really the meat of our program here. We have a lot of small things to wrap up with in our back half, but I will cease for now. Let's take a little break and pass it over to Dane and Lou.
All right. Well, yeah, first want to thank everybody for tuning in today. We rely on viewers like you with the likes, the subscriptions, the shares. All that stuff does help with the social media algorithms. So we want to thank you. We also want to thank the Puna Strong and Kilauea Recovery Grants. They help provide the opportunity for this as well as our other programs to find the support they need to really get off the ground. So we appreciate them as always. And to talk about our donation drive for the summer, I'm going to bring in Lou, and he'll talk to you a little bit about what we've been doing. Yeah, right.
Oh.
There we go.
Thank you. Well, welcome everybody. Let's get our mid-roll going here. I want to say first, thank you to those who have donated over on our website at hveri.org/donate. One anonymous donation came in tonight at $20, and a $50 donation came in from Skagitad. Thank you very much to both of you. That is the best way to support us, with a donation right there. Dane just got it up on the screen. As well as here on YouTube, we've had some super chats come in the past. I've got those up there, and it's our list of all of our supporters. It is our last week of our donation drive. We'll be ending on our anniversary. HVERI is 1 year old on Saturday. Dane and I have something special put together for tomorrow. We are going to be down and about.
Yeah.
We're going to talk about a little bit of that. Dane, go for it.
Yeah, go ahead and explain a little bit. So really we'd like to, there's a whole bunch of stuff happening down at Poiki, including the Isaac Hale Beach Park. So we want to detail a little bit, give some of the updated agendas, and talk about the different projects that are taking place. Because there's three main projects right now down there. There's the roads, which are supposed to begin at the end of the month. So we're getting close to that. We're about a month away. We also have the Poiki boat ramp dredge. So removing all of the sediment and sand and rocks that had accumulated down there since the 2018 eruption, mostly immediately in its aftermath. And then finally, we have the rework of the park there, the Isaac Hale Beach Park. Half of it was destroyed in 2018, and the rest of it's kind of been stagnant. So to pull a bunch of life back in it, and we've been lucky enough and fortunate enough to be invited by the families, the Ohana, that have been helping contribute to this, to look for anything that we can help with in terms of coming up with a good plan for the park. So yeah, we're going to go through the big three for Poiki and talk about all their impacts and what the future might hold, because that's a lot to have happening. Three major projects at one location, or focusing around one location. So that's coming up tomorrow. I think around, we'll do that at 5 p.m.
Around there, yeah.
Yeah. And
which will be great because we've never been able to live stream in certain locations around the island. We are going to be packing gear with us so that we can bring that to everybody. Kind of special, because being remote here is got its own tricks, right? And you guys see when we're out and about, sometimes we struggle with signal, but it'll be great to be able to stream from down there and give you guys an on the ground look of what's going on and tell you all about that. I also wanted to say thank you to the Atherton Family Foundation, who also supports us with one of their grants, as well as the Kau radio station. If you guys are on the west side or in the Kau district. They've been airing our summary. So thank you to them as well. That's what I have for us tonight. You do have one more chance tomorrow when we're live, and Saturday as well, to donate to us at our website, hveri.org/donate. And we are just under $2,500 for the summer drive. Also, if you're a business and you're looking for a corporate sponsor type program, please reach out to us. We'll talk to you about that. We'd love to have you here. That's it. Aloha, everybody.
All right. Thank you, Lou. And I think with that, we will get Phil back in and continue onward, huh? All right. There we go.
All right. Thank you, Lou. Thank you, Dane. Yeah, it's awesome. Yeah, and interesting to think about the year we've had in operation since we started our nonprofit services a year ago on the anniversary, 5-year anniversary of the end of the 2018 eruption. So here we are. It's been 6 years since the end of 2018. And we'll come back to talk about that more in the future, but that's just to remind you guys where we came from, why we do this, and why it really matters. Yeah, so it's all about our mission to improve disaster preparedness and response through education and network building. The networks being the platforms you guys are watching this update on today, and Catcher articles and all of our other offerings. So mahalo all you guys. All right, so now we'll turn to our volcanic hazard summary to continue our update here. And we'll do this from our usual source, the VOG Measurement and Prediction Project at Manoa. And that currently looks like this. Not a whole lot of gas is coming from the volcano. And it's coming out just from Kilauea. And with the current weather patterns, the impact is likely downwind towards Kau, Pahala, Nalehu, Ocean View. Those are the typical areas that often deal with even low-level VOG, which is at volcanic background, but still sufficiently abundant that can be irritating and problematic for people who are sensitive, and especially if you're close by, right? So those of you who are affected likely know who you are already, and just take your usual precautions. So this is really the main primary threat to people at this point in time, since all the activity underground is happening within the park and there's no flow to worry about or anything like that. International Park, everything is in the green as usual all through there, as you'd expect, with the charts historically also showing all through the green for all the reporting stations over the last 24 hours. So good air out there, relatively speaking, for Kilauea. So we'll turn now to our Mauna Loa check-in, monitoring update. And the USGS at the beginning of every month puts out an update from Mauna Loa. So here is today's update from August 1st. Seismicity beneath Mauna Loa's summit and flanks has been low. This is expected for the post-eruption phase of this volcano. That's basically it. GPS data records a very slight inflationary trend near the summit, and everything else is normal. There's really nothing else to report on Mauna Loa. We're still keeping an eye on it, but that is what there is to see. Not a whole lot right there. Looking at the tilt meter, you're seeing the daily wiggles from the tidal effects. Nothing really to worry about there. Nothing changing. Continuing background earthquakes in the shallow parts of the volcano. That's also normal. The tilt that looked like it maybe had a little adjustment 3 weeks ago looks like it's fairly stable. Right? I don't really see anything major happening through here. Earthquakes over the last month in that same shallow region, it's fairly unchanged over the month. Maybe slightly more at the right end there, but not significantly. Earthquakes per day are only reaching 4, 8 in that summit region, so very few earthquakes overall. Looking at earthquakes per week, still very low. Within the last year, this was a deep earthquake swarm under Mauna Loa that didn't last very long, and we're not even that exciting now. And compared to the last 5 years when we had the eruption in 2022, where very, very few earthquakes compared to the eruption buildup itself or any of the previous 3-4 years. So not much to report on Mauna Loa. We will then turn to our volcano watch for the week, which this week is the USGS bidding farewell to the Ua Kahuna location, the Okamura building up here. This aerial view, there's the first cliff on the edge of the caldera, the Jagger Museum, old overlook, and the all USGS buildings parking lot back here. So this, I think, I will probably read a good part of, because I think that the USGS voice is well represented here, and I want to make sure we honor that and give it justice. So, time to go. Words that none of us at the USGS Hawaiian Volcano Observatory wanted to hear. Here's a view from the tower in 2018 during one of those collapses. This was a great location to look at both Kilauea and Mauna Loa. Continuing with the article here. It was May 16th, 2018, and HVO staff had been in the throes of monitoring Kilauea's lower east rift zone eruption and summit caldera collapse for the previous 2 weeks. HVO's building, located on the rim of Pele, the name for Kilauea summit crater, was being shaken apart by as many as 400 earthquakes per day. Cracks in the floors and walls enlarged and multiplied, as did concern for HVO staff working there, until those inevitable words were spoken. Time to go. As we reluctantly left our offices that day, little did we know that we'd never work there again. Despite vacating our cherished workplace, HVO had a job to do, so staff carried on from temporary offices in Hilo without missing a beat. We didn't have time to ponder the fate of our building, although we harbored hope that it could be repaired. At the time, our focus was solely on responding to the ongoing destructive lava flows and summit collapse at Kilauea. It was only after the 2018 volcanic crisis ended that HVO staff learned that damage to the building was deemed too extensive for it to be safely reoccupied. News that the building would be razed was devastating. So I'll summarize a little bit here. HVO was founded in 1912. The original building was by Volcano House. Then HVO was in the Ohia wing near Volcano House. Then it went to the Visitor Center in 1948. And finally, in 1986 is when it occupied the present, well, up until recently, facilities at the summit, with the original crater rim building returned to the park and converted to the Jagger Museum. So if you've been to the national park and been in the museum, that was the original USGS building on that site. So HVO staff from 1948 through 2018 realized what a privilege and inspiration it was to work within Hawaii Volcanoes National Park. From the buildings at Ua Kahuna, the site provided spectacular views from which we could readily observe Pele and Kilauea's upper rift zones. As an aside, we know that this was after Maunaulu, but from this site they could see the fountains of Maunaulu on the rift zone at Ua Kahuna when they were occurring. Hundreds of volunteers and visiting scientists from around the world, as well as countless students, came to HVO to learn about and experience the only USGS observatory located at the summit of an active volcano. Well, no more, unfortunately. Volcanoes rarely erupt at the convenience of humans, so HVO staff must sometimes work around the clock when monitoring an eruption. As a result, HVO's building was like a second home to many staff, so its loss feels personal. Deconstruction of HVO's building at Uikahuna is now almost complete. For all of us who work there, saying that we are sad is a profound understatement. The loss of such an iconic facility is truly the end of an era. We take comfort in knowing that part of the building that was taken down in such a way that materials from it can be reused elsewhere. For example, rocks from its outer walls are being used in the construction of HVO's new field station near Kilauea Military Camp in the National Park. Like the former buildings at Uikahuna, the new station will allow staff to reach field sites within minutes to repair monitoring equipment or document activity as necessary. For the future, the USGS has another facility under construction at University of Hawaii Hilo, which they will share with the Pierce Unit Pacific Island Ecosystems Research Center. They're a biology division, right? So ecosystems, all the animals and critters that make up part of that, and plants as well. So at UH Hilo will be office and lab space, and then it'll have the field station to repair field sites within the national park. As HVO transitions to new environs, those of us who worked from the buildings on the rim of Kīlauea are grateful for the experience and finally remember our years there. So there is a final view of the USGS HVO building at Uikahuna during a recent eruption of the summit. And that's the USGS Volcano Watch from this week. And yeah, I am included in that as well. I remember I was lucky as a volunteer that happened to be one USGS scientist retiring and another one coming to occupy the office, but not for another month. So there was a 1 month period where this office right here happened to be unoccupied. Well, maybe actually it was probably this one right here was unoccupied. And I got to work as a volunteer with this view out the window for that month. And that was really something I'll never forget. Once the senior scientists arrived, I moved back to my little cubicle. But that was really the highlight of my workspace at HVO. Apart from those few days where I was able to put my laptop up here in a tower and work from up there and look all around, which is really fantastic too. But all that is gone. It's the end of an era. So along those lines, we'll once again turn to Yvonne, sharing some images of her own farewell to the HVO building. Some views of after they took down a lot of that site, the buildings off the side, the tower was all that was left. You see here the truck getting ready to take away some of that debris. Slightly different view. Very strange to see it so naked like that. And there, you can see what it looks like from that point of view behind the fence there. Okay, that's the post from Yvonne. And we also have from National Park a series of images from Janice Way. So here we have machinery getting ready to knock over the tower. There, the tower is down, dismantled. You see the piece of the roof, the remains of the shell of some of the building here, the Jagger Museum. This might have been the area near that park bookstore area, which is was that original construction. You see it's made out of stone here, unlike the rest of it. But one last view, USGS webcam image from the 26th, showing the tower down and the facilities. There's the restrooms still in place over here. This was that new wing of HVO that's now all the way down. Jagger Museum and back was this footprint back in here. The USGS garage over here. So much different views. And that means that in the future, there'll be much better views of the caldera, which will be unobstructed by all this material right on the rim here. So that is our farewell to USGS at Uikahuna. So that's Volcano Watch. We'll wrap it up with Community Corner. In our Community Corner, we'll mention first there are many events in August at Hawaii Volcanoes National Park. August 4th is a fee-free day, if you are looking for a fee-free day. Otherwise, in a national park, there are several talks that we will hope to bring you guys. The first one is coming up on Tuesday, August 6th at 7 p.m. This is The Forest in a Pit Crater, A Tale of Ancient Hawaii, an encore presentation of a standing room only program that was given at Kahuku. This is by David Benitez, former park ecologist, who led surveys into the crater, rappelling in there to document more than 100 plant species, many rare and endangered. So that should be a treat. Other park events happening here, Ku'i Kalo Demo, but we'll highlight volcanic events here. Saturday, August 17th, 9:30 to 11 a.m. at Kahuku Visitor Center will be Dr. Don Swanson with this very fascinating topic, Pele Inhiaka, Myth or History. This is the story of Don consulting the Hawaiian elders to reinterpret some of the translations of historic events and the chants of Pele Hiaka to extract geologic information and extract geologic history of the volcano. It's really amazing, groundbreaking work that I hope we see the likes of again. I really do. So that is the other one to highlight. And finally, following that, Tuesday, August 20th, 7 p.m. will be the Kilauea Visitor Center renovation update, because besides Uikahuna, the main visitor center is also undergoing construction and renovation. And this will be the date where we hear all the details of what that will entail. Right, so that is our community corner, with one last community corner event from today. The national park. Today, August 1st, is Hawaii Volcanoes National Park's birthday. The park is 108 years old. Today, 108 on 801. How about that? There is their Spam Musubi birthday meal, apparently. So, of course, we all love the national park. Congratulations to the park, all the community around the park, people who work there, people who live nearby, people who travel to go and visit it as often as possible, or even just once. So, mahalo National Park. All right, Dane, well, that is it. We can turn to our questions and discussion.
Yeah. All right. Yeah. Awesome. I love that little spam musubi thing. I know it's been done before, but it's always, worth a little chuckle, at least. So we do got some questions. We did get a $10 super chat from Smith. Says, thanks, love from Australia. Appreciate that. Just wanted to shout that out before we get into questions, which we're going to start with BPS, who asks, do we have any estimates of how much magma was displaced into the drift zone?
Easy answer, no. We don't have any estimates.
Yeah.
Not yet.
We'll share them when we get them, type of thing. But
yeah, we will.
All right. So with that, we have Richard next. Is this inflationary cycle extraordinary or average? We're looking at all the GPS and
it's So the tilt cycle is the deflation inflation. That part is normal. I mean, eruptions are massively deforming, and there was deformation from that. But what we're seeing deformation happening now is not so much inflation. A little bit. The stations that you see with upward movement on the GPS, there you could say the word inflation. But everywhere else, we're seeing a lot of it is lateral movement. Things moving out of the way, sideways. And in a few places, they are inflating a little bit. So the scale of that is not that much in the grand scheme of things, because in the past, magma was flowing from the source, under the summit, through the rift zone, out of Pu'o'o for 35 years in a row. And so normally that area was very pressurized and very inflated. And in comparison to that, right now we're not that inflated. We're just starting off the pathway to getting back towards that. But because we've been uninflated for so many years, in that context, then yes, it is a lot, and that's why we're making such a big deal and spending so much time on it, because this is the real thing that affects the East Rift Zone, and it's the prerequisite for any further activity in the rift zone and further on where it actually affects people. Not that we're anywhere near that yet, but this is a required intermediate step for that to happen, right? So we're progressing in that direction till one day, again, lava will affect people for sure, right? It doesn't seem like it's happening right now, but it's progressing towards being able to do that. So that's really the significance, is that it's opening the rift zone for the first time since 2021. The rift zone really since 2018. Between 2018 and 2021, it was likely open from a deep rift source coming from below, just kind of passively filling it. Was never going to erupt, was kind of just repairing itself. So really, this is the next stage of healing for the rift zone, is it actually having magma reoccupy it, to start pushing on the walls, to like tighten the walls, to make its pathway, rebuild its pathway, and find its pathway all through all the cracks and collapses and everything that's changed since 2018. So that's a good question. But yeah, I've seen a couple of other comments along those lines. You know, like it looks like things are deflating or dropping, but really, in fact, they're actually kind of contracting or moving laterally. Is more the nuance of description there, right? That's tricky. That's why I try to explain those. I try to explain those clearly. It's not always easy to do that, right? Because of those that difference right there. So I'll leave it the discussion there, I guess.
All right. I'm getting hungry looking at the spam musubi in the background there the whole time.
Yeah,
but...
actually.
No, it's fine.
We'll
do one more question.
And
then one more question from Ken. Speaking about that lateral movement, he asked, is there a total lateral movement measurement of the south flank? Is it moving or has it locked?
So it's the one section, right? That one section in the south center, or maybe southeastern center. That's the section. So let me see if I can. And I mentioned that I saw that we talked about upward movement. So let's come down here to our GPS again, and well, maybe let's go to the map so you can see better where we are. So let me zoom it in here, and if we come to, let's just pick this one, Makai, which is the closest one, and see how far it's moved to the south. And so let's see our line here. Let's call it not minus 0.02 just to make it easy, and minus 0.10. So that is about we'll call it maybe 8 or 9 centimeters sideways, at this station, right? And that's right next to the rift zone, so that's getting pushed a lot, right? So that's really the largest value. But if you come further over, go further to the south, Kalapana Trail, let's see, that's from about 1 to about 8, so that's 7, a little bit less. You go further to the coast at Holeipali, it's moving to the south, but not as much. So here it's from, call it 5 to 3, so about 2 centimeters, right? And you get all the way to the coast, Kayanet Point, right here. This is the one at the coast that's actually moving. And it's maybe moved from 5 to 7, so 2 centimeters also, right? So there you go. That's the kind of pattern. At the top, it's maybe moved 7 centimeters this far, and then maybe 5, and then 2 down here, 3 and 2, something like that.
A lot of movement though, across a wide area.
More important is that the whole thing is moving. That's
right.
The thing, right? Because you have barriers in between all through here. So you've got enough pressure on this one that it's also pushing that one, which is also pushing that one, which is also pushing that one. And that's what I mean about lock and closed all the sides of the pathways, right? Until you have pressure, you can't do that. So the magma has come in and put in pressure, it's closing those areas. Now it can start pushing to the east, to the rift. And everywhere further east it goes, it has to keep doing the same thing. It has to keep pushing cracks closed there and wiggling things around. And maybe that's why this station at Okita is bouncing all over the place.
Right. But the answer to the question, is it moving or has it locked on the south flank, is kind of just moving. Yes. It's both. Like you have sections.
It's not locked. Moving. It's moving. Yeah. Right here it's moving. Yeah.
Yeah, right there it's moving, but you have sections that aren't moving, essentially.
That's true.
It's a big flank. It's a very big flank.
Over here is not moving. Right. And over here is not moving. So for example, MP3R here, not moving to the south, right? And this station is, that was right here, just to the south and east of Pu'o'o. Right, so here's Pu'o'o right there. Right there is not moving to the south.
Yeah. All right. Well, I think that does it for the questions and everything. Again, we will be live tomorrow around 5 p.m. from Po'iki. Lou and I going over all the new projects that are going to be beginning finally after 6 years to regenerate and regrow Poiki. So yeah, join us for that.
That'll be awesome. Yeah, bonus live for you guys tomorrow. And mahalo Lou and Dane for heading down there to do that. So I'll see if I can join. I'm not quite sure yet for that.
No worries.
All right. So yeah, mahalo everybody. It's been an exciting week here. If apart from tomorrow, if something else occurs in the meantime before next week, we'll jump back in with an update for you guys. However, things are likely to be moving at a fairly slow pace once again now. As you guys have likely learned, the volcano moves in fits and starts, and so we just had a big pulse. We're adjusting now. It's adjusting a lot, but we'll see when magma is reestablished into that area to pressurize and cause more earthquakes and a further chapter in our story here. So something else will have to happen to bring us back into balance still. So until next week or sooner or tomorrow for these two guys, from HVERI, the nonprofit Hawaiian Volcano Education and Resilience Institute, I am Philip Ong, Mr. Dan DuPont right above me, and our ASL interpreters, Dano and Kīri. Mahalo to you guys, as always, every week. We appreciate you making our content accessible to a wider audience, making sure the deaf community on Hawaii Island is also informed and prepared for these events. Super important things. Mahalo, Kīri, and Dano. So, with that, until tomorrow and next week, from HVERI, Dano, Dane, I'm Philip. Aloha, everybody.